Good morning or good afternoon, wherever you are. Uh, Welcome to episode 5 of our series, Probability of Default. My name is Rafael Castillo-Triana. I've been writing the book of Probability of Default under the pen name Ralph Castle. I want to welcome for joining this episode 5, and I hope that you are going to enjoy uh, and get a lot of advantages out of this presentation today. Let me first start to call the attention of why this is important. I would say that one of the basic observations is that we, all of us, are constantly exposed to the risk of default. Whether you are an independent professional or contractor, your clients might default and you may lose your work. Whether you are investing your savings in companies that you don't know if they will default. Whether your money is in a bank who is lending money to individuals or businesses that might default. Whether you are an employee and your employer might default so that your expected salary might not arrive to you. All these are elementary situations that may happen in life. Now, one of the things that happened to me during the pandemic is that I realized that the pandemic will bring some increased exposure to credit risk. And the thing is that we didn't realize the consequences of that. Personally, I had a lot of concerns about that, and I'm going to share that with you in a moment. But just looking from the standpoint of you as a subject who is moving in a society based on credit, there are certain questions that I want to invite you to ask yourself. One is if you have experienced frustration when you have applied for a loan at any financial institution. If you believe that you have been powerless in front of a system that judges you unfairly and wrongfully. And I will say clearly and bluntly that that probability of default is something that has been lightly taken. And here is exactly my concern about what the pandemic brought to us. When the pandemic started, I was concerned that credit risk was going to be one of the main casualties that will happen as a consequence of the pandemic. And I will say that in many countries, what happened is that the government, the regulators, allowed the banks and financial institutions to restructure the loans or the leases or the facilities given to the obligors, to the debtors, without really drilling down on how the probability of default would have increased. Now we are experiencing, and in particular in one country, which is Mexico, and I will tell you why this is currently happening in Mexico, but it's a shoe that is going to fall in all the other countries. In Mexico, what is happening is that there are several financial institutions that already have been falling down as a result of the likely approach taken in connection with the judgment of probability of default. And the thing is that with that, in taking into consideration, there have been at this moment 5 non-bank financial institutions that have been going busted in in Mexico. Uh, and uh, and the count is not finished. There are many others that I'm fearing are going to fall into the same situation. So what happened? Well, the pandemic certainly impaired the ability of most of the obligors to pay their loans. And and the only resource that was used at that moment was, okay, why don't we extend the terms so the default is not apparent? It doesn't happen now. But the pandemic is over. The extension capabilities or the abilities that were given to the entities to provide such extensions are over. And then finally, these institutions were facing a situation where they have non-performing loans and they should write off. The most recent in Mexico, a financial institution called Mexarrend should write off $24 million in bad loans overnight. And this is a big deal. And this is a big deal because it shows that we certainly took lightly the subject of probability of default. Now, what happened in the other countries? The other countries have a little bit more protection because the government, as opposed to the case of Mexico, the government in countries like Colombia, like Peru, like probably Costa Rica, Chile, also provided some government facilities that provided collateral to obligors that eventually would be facing difficulties. But no one really went into the point to try to understand the issue of probability of default. So what is the reason for that? And that goes to the first question I have for you. Because people take this lightly, because people have not really drilled down in trying to understand how you can build your own credit culture. If you don't have your own credit culture, it is going to be impossible for you to manage your risk. What people does today is that instead of building its own credit culture, which is the result of what you have learned together, I mean, taking the experience of your peers, taking the experience of your stakeholders, which all these learnings provide you what to believe in and what not to believe in. And then that goes into embracing values. What is more valuable than other things? But what people does today is that they borrow someone else's credit culture. So they go into Standard & Poor's, they go to Moody's, they go to Fitch Ratings, KBR, a Kroll Bond Rating Agency that actually is the former Duff & Phelps, another credit rating agencies. They have some models, they provide some packages. You buy the package and you believe that you have a credit culture. I have news for you, you don't. So here's a situation that we are really finding in terms of our current approach concerning credit culture and probability of default. And I think that we need really to focus a little bit more in learning better about how to build your own credit culture. So if you had not the chance to access episodes 1, 2, 3, and 4, that were the precedents to this one, I will invite you to do that. The episodes are online in YouTube. And I think that they will give you a good idea of how we have been following this learning curve, going from the basics, learning from the basics, learning from the masters, how default happened, how probability theory applies into our risk management capabilities. So today, we are going to focus in an additional analysis. You may recall that in the past, we talked about default, we talked about what we have learned from the science of probability, going to the people through history. So we went from Fibonacci, who brought mathematics to our world. We went to the Chevalier de Méret and Blaise Pascal and Pierre de Fermat, that actually build what is today the theory of probability We went to the law of large numbers that also has been driving a lot of the analytical of the issue of probability worldwide, and in particular, what is the root and the basis for the business of insurance. But now, after taking into consideration this, which basically uh, helps us understand a little bit how probability is being built based on the situation or the reality that we can anticipate what's going to happen in the future. We can be prepared for that. And it's a little bit of due diligence, a little bit of homework that we need to develop in order to be prepared. And that's what probability is all about. And in the case where you are really trying to anticipate what will be the effect of default in your business, certainly is a homework that you need to do. Today, we're going to focus on something important, because we tend to believe that credit risk is based on financial analysis. And in a way, financial analysis is a key component of that, but it's not the only one. Most of the existing models actually devote their analytics to analyzing financial ratios. But we tend to forget that the applicant of a loan, that the obligors are human beings. And in the case of companies, corporates, they are managed by human beings. So it's important that we can review the human side of the probability of default. And it's interesting, we are going to focus in this episode 5 today, about this subject. And episode 6 is going to focus on the issue of character, how character is important to, and how you can use analytical and scientific tools to measure character as a component of a probability of default. But today, what we are going to learn is how the human factor help us define our risk appetite framework. And this is important for basic reasons. Number one, because Basel IV is all about that. I mean, the Bank of International Settlement have been urging financial institutions to define from the get-go what is the risk appetite framework. The Central Bank of Europe has a strict regulation on that point. And IFRS 9, the International Financial Reporting Standard number 9, that applies to companies that abide to the best accounting practices, also contains a specific judgment that is based on this concept of the risk appetite framework. So that's the importance of our episode today. We should learn about this. So let me recap a little bit why and what has been the journey, the trip that I decided to take, and where I'm inviting you to join me, not only through the book that was written and was referring in a minute, but also through all this series of webinars. And the journey is trying to understand from the basic concepts. So the first one is landing into the concept of probability of default, understanding what default is all about, and then getting into what probability is all about and how history has built a very robust theory that is exciting, is amazing. Today, we are going to focus on the risk appetite framework. But then our next chapter is going to be the neglected analysis of character. And then we are going to drill down to arrive to what could be a credit risk analysis model. You can call it a credit scoring model if you want, but essentially it's a methodology to measure your probability of default. Now, if you are in a hurry, all that is in the book. So you just going and getting in Amazon the book and reading the book. I did my best not to be extremely boring. I must confess that this is a passionate subject, and being a passionate subject, I think I wrote this with a lot of passion in humility, because we are certainly learning from the masters. A lot of things that, quite frankly, I either didn't know from my education, from my formal education, or I simply neglected to pay the deserved attention to that. And today we are going to receive also the visits of some of the masters that help us understand all these concepts. So when we go into the concept of probability of default, the question is, how do I know that the person who owes me money is going to pay me back? And the specific is, how do I measure the probability that that person is willing to pay me? So we are not talking about only the fact that that person can pay me, but also we are going to define what is the odds that that person is willing to pay me. And we are going to get some interesting tools today. Now, what is the importance of the risk appetite framework? I'm having this image of the elephant taking its own belly because what we learn about appetite is that our appetite framework is given by the size of our stomach. By the same token, if you are a financial institution or if you are any kind of company that is taking risk, the first question that you need to ask yourself is if you have the size of the stomach that allows you to undertake certain risk appetite. And that's exactly what this concept is all about. The point is how we are going to define what is the size of our stomach, how we can really digest the risk that we are taking. And this is something that is a scientific concept, and it's amazing to learn how this works. So let me recap a little bit what we have learned up to date. The first concept that we learned is that default is a human behavior where character plays a big role. The second key learning is that probability emerged as a scientific concept when mankind, with the people, with men and women, understood that the future can be anticipated, albeit not necessarily predicted. We cannot predict, but we can anticipate the consequences of the different alternatives that may happen in the future. Probability science, that's our third learning, is rooted in mathematics. And the starting point came with the seed of Fibonacci. So you may remember in the corresponding episode, we told the story of Fibonacci, Leonardo Pisano, the figlio de Bonacio, how he embraced from the Arab culture something that was brought in our knowledge in the Western world, which is the basis of all our arithmetic and algebra and all the mathematics that we know today. But also the most important part is that it set the foundation of probability. And then gamblers, I mean, the impact of games into the development of the probability theory is amazing. Gamblers like us, Fra Luca Pacioli, Girolamo Cardano, the Chevalier de Marais, Blaise Pascal, Pierre de Fermat, they all produced the big bang of probability theory. And that was a combination of mathematics and games, and how you can really sort out the expected outcomes of a game in applying mathematics. Then we landed into the concept of data and how data came to enhance the application of the probability science to disciplines and businesses such as insurance. And we need to really give thanks to John Grant, Edmond Halley, the same guy of the comet, the Bernoulli family. We are going to receive the visit of another Bernoulli member of the family, Abraham de Moivre, probably according to Napoleon Bonaparte, one of the best mathematicians on earth, Bayes, Markov, Gauss, and Galton. All these we could review in episode number 4, and how the use of techniques of the Monte Carlo simulation really developed further the concept of probability. The problem is that when you go further and you fall in love with all these developments, you tend to forget the key essence of probability of default. I mean, you can really interpret the law of large numbers. Is going to be very useful for certain points, but is not necessarily what you need to apply when you judge probability of default. Now, the question today is how human behavior can be approached. And that we call skills in the game. Not a skin in the game, but skills in the game. Well, you could see LeBron James recently scored 40 points in a match. Unfortunately, they lost. But clearly, a winning team is a team that has the combination of good luck and good skills. Probably when you are playing roulette or you are tossing a coin, you rely much more on lucky lady luck rather than your ability. But this is a combination of the two factors, luck and ability of the people. And we need to see that from the perspective of two parties, the lender and the borrower. So here comes Daniel Bernoulli, a very interesting person. He is the nephew of our good friend Jacob Bernoulli, which was one of our visitors in episode 4. Uh, and what Daniel Bernoulli is important about is that without him, we wouldn't be able to take a plane and fly because he developed the aerodynamic theory without which, the wings of a plane couldn't lift off. But we are not going to focus on his contribution to the physical world, and that is going to be a different concept. Our focus today is the contribution to probability that came from his writings about the relationship between utility and wealth. And this is a very profound thought. Just to give you a little bit of history, Daniel Bernoulli, he was born in what is today the Netherlands. It was at that time part of the Spanish Empire. They moved because they were Protestant. They moved to Switzerland, and that's the reason why a lot of the literature judges that the Bernoulli family is a family of Swiss mathematicians. Actually, Daniel Bernoulli and Jacob, all of them, they were born in what is today the Netherlands. But this a very interesting story is that when Peter the Great wanted to really make great Russia, this is interesting of what is happening today as well. He came to the West specifically, and he tried to recruit the best brains, the best scientifics. And then Daniel Bernoulli was invited to be one of the lecturers in the University of St. Petersburg. He was in St. Petersburg then when he developed this theory about the relationship between wealth and utility. And this is important because when we are talking about a risk appetite framework, the ratio, the relationship between wealth and utility plays a very important role. So when Bernoulli asks, the question is, how can we measure our risk appetite? Bernoulli tells that there is an inverse proportion between anyone's wealth and the utility. And that's just an observation. I mean, if you own $1 million and you earn $100, the utility for you is not as important as if you own $1,000 and you earn $100. Clearly, the utility of earning $100 is greater if your wealth is smaller. So there is an inverse proportion between anyone's wealth and the utility. The second observation, which is probably one of the most interesting concepts he brought to life, and I would say that we should really learn from that concept, is that wealth is not tangible assets. For Bernoulli, wealth is human capital. And he defined human capital as the sum of education, natural talent, training, and experience that comprise the wellspring of future earning flows. So your wealth is not what you have, is not your car, is not your house, is not the stock you own, is what you have as ability to generate cash flows in the future. Because every other thing, your house, your car, your stock, they may eventually disappear overnight. The only thing that is left for you is your ability to generate income in the future. And that was a very, very interesting observation because it went to an extreme that is also very interesting, which is a beggar has wealth. I mean, someone that is begging all the time for money at the exit of the church or wherever you want in any corner, and they are begging and begging and begging. So the exercise that Bernoulli undertakes is if I offer the beggar to stop begging, for how much the beggar will really stop begging. And he made exactly this calculation based upon certain point that will define exactly what is the appetite of the beggar to stop begging. Hmm? How much money you need to pay him. So the example he says, let's suppose that the beggar makes in the alms that he collects every year, 10, let's put it in terms of dollars. Of course, the currency at his time was very different, but let's say it's $10, 10 rubles, and you offer him 50 to stop begging. He will probably reject that. But if you offer him 100, he probably will accept that, of course, because he may consider that that his ability to beg could last 10 more years. So it's a good deal for him to evaluate his business of begging in 100. So it's very interesting because that shows exactly the measure of wealth. And interestingly, when you evolve and you enter into the field of M&A, mergers and acquisitions, and you try to figure out how to value a company, well, the same rationale that he applied in these writings, which I will encourage you to read if you want. Of course, part of that is quoted in my book. But you can go to the original document that was translated in 1956 by the University of Princeton. And this is the commentary that he made in the University of St. Petersburg about the measure of, is a new measure of, a new theory of measuring value. So this is very interesting for us. So let me go down into what Bernoulli quotes in terms of the exercise. And the first distinction he makes is that the price of an item depends only on one thing, which is the forces of the market. But the utility for the receiver of that price depends on the particular circumstances of the person that is making the estimate. Again, that goes into the same theory of the beggar, but it can also go to your own appraisal of your value as a professional. Think about it. One thing is the price you put to your services, and the other thing is what is the utility that you are going to take out of the value you receive. So Bernoulli take us into this interesting exercise. He mentioned that Caius is a Petersburg merchant who has purchased commodities in Amsterdam that he can sell in Petersburg for 10,000 rubles. So he has the possibility to earn $10,000 more. He orders them to be shipped by sea from Amsterdam to St. Petersburg, but he's doubting whether or not to insure them. Why should he insure them? And the answer comes in the next paragraph. He said, because he knows that out of every 100 ships that sail from Amsterdam to St. Petersburg, 5 were lost. Only 95 arrived safe in these times and age into St. Petersburg. You may now, if you convert that into modern terms, to believe that probably the probability of losses of sinking ships between Amsterdam and St. Petersburg could be lower, depending, of course, of the war. But in any event, the rationale is interesting. It's 95 that arrive safe, 5 that are lost. Now he goes and quote the insurance, and the insurance happens to cost 800 rubles. So at this point comes a very interesting question that Bernoulli asks. See, how much wealth must Caius possess in order to abstain or buy an insurance, in order to self-insurance? Okay. And how is the methodology? So in order to get there, he comes into a concept that we already review in one of our prior episodes and is in detail analyzed, which is the concept of expected value. You may remember that Girolamo Cardano, when he started to analyze the different compositions of the different outcomes when you toss a coin or you play the dice, uh, you can really estimate what is your expected outcome or the expected value. And the expected value, according to Christian Huygens, ended up being the average of the total outcomes, winning or losing. This average, according to Bernoulli's equation, is the root at power 100, because we are talking about 100 ships, that will take a situation where X is the current wealth of Caius. We don't know how much is that. Plus 10,000, that will happen 95 times. So that's the reason why this equation goes into the power 95. Multiplied by X, which is just the wealth, because we didn't get the 10,000 in 5 cases. When the 5 ships sank, we lost the $10,000. So our wealth is still X. So the expected value is root 100 power of X plus 10,000 at the power 95 plus, times X at the power 5. If you simplify that equation, that will be the same as the root of power 20, and X plus 10,000 will be elevated to the power 19. And then, of course, X will be just multiplied one time. Bernoulli, according to his calculation, X ended up being 5,043. I must confess that I couldn't really find out how he reached that result. I use Excel to try to make that calculation, because the calculation is basically making equal, as you could see below, X plus 10,000 at the 19 power times X equal to X plus 9,200, because if you have at the 100 rate, because if you pay insurance, you will have a net 800, but you will have a net 800, net 9,200. You will have that in the 100% of the cases, because you already paid the insurance, but the insurance is going to pay you even in the case that the 5 ships went down and you lost it. So in order to define what will be the amount of your wealth to insurance or not, the break-even point, if you want, is going to be 5,043, according to his calculation. And again, as I was telling you, I'm not sure if that is the number, but the concept is valid, and is the same concept that we can use. I tried to validate that. So I went into Excel trying to make that calculation, didn't work. Then I asked one of my friends who is a genius in mathematics. He couldn't do that. Then I discovered the chat GPT, which is, as you know, one of the artificial intelligence assistant, the most famous now, supposed to be the Kodak moment of Google. I asked the bot to help me in that calculation, and it couldn't. Now, later on, I discovered that this assistant in artificial intelligence is not very good at math. So anyway, but let's believe that is 5,043. The important part is not exactly what is the number. The important part is the methodology that Daniel Bernoulli applied in order to define what is your risk appetite framework. And we're going to see that a little bit more. Now, he went further and he said, okay, it's not only the case of defining how much wealth you must have, we also need to be a little bit smarter in terms of risk. And basically what he suggests in this case is that if you have certain amount of goods that you need to transfer from one side or the other, it is probably a better idea to split the amounts to diversify your risk. And again, he uses this uh, mathematical approach to the point that in this particular case, what he says in any different, we aren't talking about insurance here. We are just talking about how you reduce your risk by splitting in different shipments the goods that you have bought. He changed the number, he changed the example. Now it's not Caius, it's Sempronius. But at the end of the day, the example goes to be more or less the same. And using the same expected value approach, he ended up to say you can really make different combinations of how many different. This is, of course, taking into consideration that in this case you are losing two times two shipments. In this case, you are losing one shipment. And what he says is at the end of the day, if you combine all the different possibilities, the best value you can get is 7,200 ducats out of this because of the application of the diversification theory to reduce your risk. Now, the question is, okay, how can you really manage that in an interesting and effective way? So the point is, how much diversification should be optimal, and calculating the expected value will require multiply the outcomes at the power equal to how many times they happen, and extract the root of the power equal to the total number of outcomes. In that connection, his uncle brought a very interesting concept, which is now what we call the E number. It's probably one of the most important numbers in mathematics. What the Uncle Jacob did was calculating reinvesting capital, having 100% annual yield. If you reinvest the capital as many times as you can, what is the maximum value you could get? And that is exactly what took this equation to the concept of what today is number E, which ended up to be 2.71. So what that means is that you reinvest in each second the amount of money that you lend at an annual rate of 100%. You end up at the end of the year with $271 because of the application of the E number, which, by the way, is called E because of Euler, not because of Jacob Bernoulli. But Jacob Bernoulli was the first one who launched the concept. Steve Wozniak, the co-founder of Apple, one of the things that he did with his machine was calculate the number of digits after the two in the E number. That's the passion that this number generates is a very interesting point. But the concept here, or the important part of that, is that using E is a way to help us define our appetite of our risk appetite framework, considering not the possibility to transfer risk, which is what happens with insurance, but the possibility to diversify our risk. And that goes a little bit to the modern world when Harry Markowitz, who ended up being the Nobel Prize of Economics in 1990, developed an interesting theory, which is a portfolio theory, very much applicable today for the experts in investing in stock exchange. And basically, he weighted expected gains by the undesirable consequences, that is, by the expected losses, within a diversified portfolio to deliver efficient results. So in a way, if you are in the business of lending money, if you diversify your obligors, your economic industry, you can really mitigate or reduce your exposure to risk, but you can do it in a way that should follow, let's say, the equation that Daniel Bernoulli suggested, which was sophisticated, by Harry Markowitz. And his disciple, William Sharp, he produced what is called today the capital asset pricing model, where he introduced probably the most important part is the concept of beta, which is the variance of any given stock with respect to the average returns of the market. And that is exactly the basis of defining the concept of volatility. Uh, Interestingly, and you may remember that we talked about them last episode, the Black-Scholes model went further, ignoring the skills of the game, and then they developed a model of pricing options that, unfortunately, when they applied that in the long-term capital company, they went bankrupt because they ignored the skills in the game. But anyway, all these theories, all these ways to measure what is the connection between utility and wealth, how this is important to define when you need to transfer the risk to a third party, that is insurance. How do you need to manage the diversification of the risk in order to amplify your risk appetite framework? These are the basic learnings that we get from Bernoulli. So the question for you is, how much risk are you willing to take? That is exactly the risk appetite framework. Certainly, we learned that it should be measured given your existing wealth and the utility that you are taking. And certainly, thanks to Bernoulli, Fibonacci, Pascal, Fermat, and Newton, all our good friends from episodes 2, 3, and 4, the number will be the area of the utility curve. And that number, I mean, how you calculate this amount is going to be a mathematical result that is going to be the area of the utility curve. And as you know, by Newton and Leibniz, that will be the integral of the curve of the equation that defines the curve. Now, the equation that defines the curve, as we could see, carries E for diversification purposes. Therefore, what calculus shows us is that in order to calculate the risk appetite framework, you need to involve natural logarithms. You may remember also in one of our prior learnings that natural logarithms are the logarithms, I mean, the powers that simplify. When you use logarithms, you don't need to multiply, you need only to add the number in order to get the results. So that makes your calculation easier to follow. When you calculate the logarithms on a base E, you find your risk appetite framework from the mathematical standpoint much faster. Now, we are looking at one side of the equation. We are looking at the lender side. Now, you need to anticipate what will be your obligor, your debtor attitude, how the debtor is going to make a decision in order not to default. And that brings us to another visitor. Another of our guests is John F. Nash Jr. You may remember John Nash by the movie A Beautiful Mind. And of course, this guy is not as handsome as Russell Crowe. And certainly his wife, Alicia, is not as beautiful as Jennifer Connelly. But the story of this individual is really amazing because he made a very big contribution to decision-making process. And basically, what Nash observed is that in order for a negotiation, and of course, we are talking about negotiating with our obligor. If we are granting credit, we are certainly negotiating. What Nash observed is that a sustainable negotiation, a negotiation that really stands, is that is a win-win game and not a zero-sum game. Sometimes silly people, immature people, believe that when they win all and the other party loses, they really won. I mean, probably they won a battle, but they lose the war because everything, every personal, every human relation is a long-term relation. So Nash observed that and said, if you want to really be good negotiator, you need to look for a win-win solution as opposed to a zero-sum solution. I win all, the other party loses all. So he came out into the equilibrium theory that has been illustrated by the famous prisoner's dilemma, uh, where he says both parties' utility, again, we go back to the concept of utility that Bernoulli brought to mind, must be equivalent in order to achieve an equilibrium. And what is then the concept of the prisoner's dilemma? The story is the following. The prisoners, the police takes two prisoners. They are guilty of a minor charge. Probably they basically cross a light, a red light traffic signal or something. But they are looking because they are suspect in, let's say, robbing a bank or committing a murder. So they take in separate rooms the two prisoners. And the two prisoners, each of them are facing a dilemma. And that's this matrix shows exactly what should be the mindset of the prisoners. So prisoner one has two alternatives. He can either stay silent or he can betray his partner and testify. If he stays silent, he will get one for the minor charge, 1 year in prison. And his and if his prisoner two stays silent as well, he will get one as well, 1 and 1. If prisoner one betrays and testify, he will go free, and his friend is going to receive 10 years in prison. If the other party does the same, it will be exactly happen, exactly the same. Prisoner one is going to be 10 years in jail, and prisoner two will go free. If they both betray and testify, because both betray, they can get a reduction of the maximum penalty, and they will get 6 years each one. What is the best outcome for the prisoners? Certainly stay silent. So I believe that if they made that analysis, they stay silent and they get the best income by staying silent. So the important part here is, of course, the ability that you have to analyze the different alternatives of both parties. So getting into the context of credit, equilibrium happens when the lender and the borrower both win if the borrower performs as agreed. And this is what we need to generate when we are managing risk. We need to anticipate the human consequence, the human judgment of our obligor. Is better for the obligor to pay us than to default? And we have seen that in many, many cases. There are certain cases that, from the practical point of view, the borrower believes that it's better to wait until a litigation takes place, because he's going to have 3 years in advantage using the asset, for example, if you are leasing the asset, until you are able to really gather a judgment that will force him to return the asset. But he's going to have 3 years in advantage without zero payments. So all these kind of situations are the situations that you need to take into account when you consider your risk management and when you consider the prisoner dilemma. Now, in practical terms, the question is, how do you assess a win-win relationship? And here the contribution is made by Professor Roger Fisher of the Harvard Business School. Professor Fisher and William Ury, who was one of his students, they wrote this book, Get Into Yes, that I recommend to everyone, all of my friends, to have a good reading of this book, because that's the way you can assess a win-win relationship. And the example that they use is the example of an orange. If two ladies are fighting for an orange, how do you really solve the conflict that they have? And Salomon will suggest probably to get a knife and split the orange into equal parts. But no one really realized that one of the ladies wanted just the peel in order to do marmalade, and the other one was the pulp in order to make orange juice, because nobody really inquired about the interest of the party. So the lesson learned here is that you need to understand the interest of your counterparty. You need to understand the interest of your obligor, of your debtor, whether or not it will be in his best interest, in business utility. And that's the important part of what Bernoulli contributed to default or not. And for that reason, the conclusion that we get is that in your credit underwriting, you must identify the utility wealth components of your obligor. Is not just making a financial analysis about the quick ratio, the liquidity ratio, the capital. We are going to go there as well. But here, the most important part is to identify what is the utility for your obligor to pay you or to default to you concerning the wealth components that that obligor has. Now, let's develop a little bit the exercise coming into the modern world of what we learn from this. And I'm going to take this example that is important, but I will encourage all of you that belong to a financial institution to do that, taking into consideration your actual data. In this example, what we have is a bank that has total assets of 100. From these total assets, the bank has 10 in cash, 15 in government securities, 20 in mortgage loans, 15 in equipment leases, 30 in unsecured loans, and 10 in other assets. Probably is fixed assets or any other thing that really doesn't deliver too much value. Now, the first exercise that we suggest to be done is that you need to calculate the distance to convert into cash all the assets of that institution. Why? Because you need to understand that your worst case scenario as a financial institution is that all depositors come and demand you to pay the money. So how are you going to be able to liquidate your assets to be able to meet and pay all your depositors? Well, the thing is that in order to define that distance, you need the help of your experience, your historic data, and you need the help of calculus as well, because that will give you two components that are important. One is, what is the time that is going to take for you to convert into cash this asset? And number two, what is the cost that in terms of cash that is going to be involved with the liquidation of these assets? So we are taking into consideration certain, let's say, assumptions like, of course, to convert cash into cash, the distance is 0 in time and the cost is 0. If you want to convert government securities, the distance to cash is at least 1 month, and or fraction if you want, and the cost of that distance to cash is going to be estimated in 1. Again, you can fill the data based on your own realities. Mortgage loans. How much does it take to execute, to enforce a mortgage? In my experience, at least 12 months. And what is it going to cost? Around 20% of the value, which is what I pay for legal fees and other expenses in order to enforce this mortgage. In terms of equipment leases, what is the time distance in months? And again, according to my experience, 6 months. Worst case scenario, 6 months, and we recover the asset. How much is it going to cost me? Well, more or less 2, which is like 15% of the total cost of the assets. Unsecured loans. How long is it going to take for me? 18 months, 1.5 months. I mean, it's a big litigation. It's going to, I need to secure or garner any assets of the individual, get some liens there, need to pay a lot of money to the lawyers, at least 30%, plus other expenses. So it's going to cost 9. And other assets, in order to liquidate them, it's going to take me 3 years, and probably it's going to cost me 70% of the cost of all these assets, because probably we need to get a big cut on that. So when we estimate all these, when we can move into the next step, which is, well, I already said exactly how we calculate the distance to cash, but there are certain things that are important to take into consideration. For example, why I say that government securities are not zero. And here's the point. If you look at the way as Basel and the regulations of your country, what is the superintendencia's regulation, provides in terms of the factor, the risk weighting factor of government securities, they put that at 0%. That's a mistake. That's not true. Government securities have a distance to cash. And if you go there, if you want to drill down, the Bank of Canada and the Bank of England, they produce updated sovereign default databases showing that not all sovereign debt is equivalent to cash. And it's interesting. You can go after, in my book, we have a table, and this, in a way, this radar summarizes the situation of sovereigns. You can see, for example, the champion of defaults in the world is Iraq. Number 2, sorry to say that, but that's the numbers. Number 2 is Argentina. Then you have 3 Sudan, 4 Brazil, 5 Greece, 6 Russia, 7 Cuba, and you can go and go and go and go, and we'll find several different countries that are ranked by the amount of delinquencies, the amount of default that they have incurred between 1960 and 2022. So can you say that sovereign debt is close to cash? No, you cannot say that. You should not say that. Now, how we calculate the risk appetite framework of our expected losses based on this type of assets. And I think that this is the important part that I want to call your attention, because that's where you can do your own exercise based on your own data. So if we take the expected value formula, so you can define what will be the actual risk-weighted asset that you need to apply to the corresponding category. So for example, in cash, the value is 10, the expected value lost is 0, so risk ratio should be 0. In government securities, the expected value lost is 0.08, so your risk ratio will be 1%. In mortgage loans, your expected value loss will be 4, that is 20% risk ratio, and that's based on the calculation we made. In equipment leases, your expected value loss is 1. So the risk-weighted asset category for a lease should be 7%. Again, that is based on my experience. If someone has a different experience, that, for example, the time to liquidate a lease asset goes more than 6 months, and the cost of liquidation is higher, that probably the risk ratio is going to be higher. On unsecured loans, so the expected value loss will be 13.5, and the risk ratio will be then 45%. So unsecured loans that are currently rated for 100%, the actual ratio should be 45%. That's based on the reality that it will take us 3 years to liquidate them. I'm sorry, 18 months to liquidate them. And other assets, we are going to lose 21. So I will say that in this case, for other assets, the risk-weighted asset will be 210%. So this translates into specific issues, which is, based upon that, how much wealth should I have to afford such expected losses? And then that goes into the basic equation that shows that the expected value loss should be equal to the probability of default times loss given default times the value at risk. So if we assume a Pareto distribution between the probability of default and the loss given default, meaning probability of default weights 20% and the loss given default is the 80% of the total loss. So that will give us the point that the loss given default, of course, in the case of cash is going to be 0. In the case of government securities, is going to be 0.44%. In the case of mortgage loans, it's going to be 16%. In the case of equipment leases, it's going to be 5.33%. In the case of unsecured loans, 36%. And other assets would be 168%. Put that into the equation that you find down there, which gives you all the combinations, all the expected value, all the outcomes of this game. So you will finally arrive into a number of 8.23% of the total assets. Interesting. That's the wealth that you need to have when you have that composition of assets in order to be able to pay to all your depositors. Interestingly, because Basel I and Basel II put a minimum required capital for financial institutions at 8%. So making a different approach, I don't know how Basel made the definition of the 8%, but making this approach, we calculated that your wealth, your risk appetite framework will be defined by this equation. And then the result is 8.23% of your total assets. Isn't that interesting? So what have we learned today? We learned today that probability of default cannot be dealt without considering how humans make decisions, taking risk of lending or taking risk of defaulting or not. Daniel Bernoulli, in his 1783 paper in St. Petersburg, brings us a very valuable perspective, which is reinforced by the lessons learned from others like John Nash, that lead us to understand how well the risk is determinant. While in any credit underwriting, we should perform the exercise of the prisoner's dilemma. Please do that in your credit underwriting processes. And that, in order to set our risk appetite framework, we should apply active data to calculate our capital allocation to the exercise of dealing with probability of default. And that is our episode number 5. Our next episode is going to be the neglected analysis of character. I promise you that is going to be very enlightening because this is going to show us a reality. But I want to stress before we leave how important it is for us to pay real attention to all these steps to learn about probability of default and building our own culture, not borrowing from someone else. I have a recent case, and I want to share that with you, where we undertook our own analysis of a very interesting client for a leasing facility. We were submitting that to a multinational, a Japanese multinational. That Japanese multinational happened to use the Standard & Poor's IQ model. And the IQ model made it impossible to do the deal because the IQ model is based on certain biases. And the first biases are large weight of the probability of default is given to the size of the assets of the obligor. So if you are a small to medium-sized enterprise, you don't qualify. You're out. 45% of the total consideration is going to take you out, regardless of whether or not you have good financial indicators. And the second one is the sovereign risk of the country. So if you are in any Latin American country, the only country that is currently investment grade is Peru. And I, knock on wood, trying to keep that in spite of all the political events. But the point is, if you start by that, where 80% of the weight of the definition of what Standard & Poor's bring to you allow or take you to leave money on the table. So you are certainly doing a really poor service to your business and to yourself. So build your own probability of default culture. You need to do that. That's urgent. This is something that now is going to show up. Take a look to your existing portfolio and try to develop an independent analysis because it may bring surprises to you. The effects of the pandemic are starting to be seen, and that may take you by surprise. So this is a very important encouragement. Before we leave, I would open if any one of you want to want to ask any question. I am allowing you to unmute yourself. And in case you don't have any questions, I will be happy offline to drill down on some concepts. And in an event for you and someone that missed this episode is being recorded and is going to be broadcasted in YouTube in my personal channel. So here you are, and if there is any question, please let me know. Otherwise, I will wish you a wonderful week, and hopefully things are going to look better for all of us in the rest of the year. Thank you very much for your attention.
Gracias, Rafa.
Okay, thank you, bye.